Hi, my name is Wendy Dobbins. I will be doing my project on supernovas today. This is for Science 101, Foundations of Science, winter session 2019. So what is a supernova is our first item of topic, and this really starts with the discussion of star size. There are different sizes that a star can have, and the size is going to determine how much matter and ultimately how much energy can be generated from that particular star. So very small stars rarely result in a supernova, and there's a few cases that we'll talk about later that can occur for stars that are smaller. But most of the time supernovas occur with very large stars. We can call them massive stars. And this is basically where the star runs out of fuel and explodes. So looking at the forces kind of acting upon a star, first you have gravity. Gravity acts upon all objects that we have an understanding of. All matter is attracted and pulled towards each other, and the larger the mass, the more gravitational pull. So very massive stars have kind of this inward pull generated by gravity. But stars, since they are burning fuels, they are doing nuclear fusion, and this generates a very large amount of pressure. This pressure is kind of the outward force that pushes out and opposes gravity. So these two forces are constantly kind of battling. And when a star starts to die, or it's basically running out of fuel, what ends up happening is that the gravitational force doesn't really change, except that some of the material does. You're left with some of the heavier, denser things, so it can actually increase gravity. But what occurs is a very quick shift and lessening of pressure. The lessening of pressure causes the gravity to overcome that pressure that was being used, and it actually collapses in on itself. Most of the time it happens so fast that it generates an explosion. And there are some exceptions to this. There are some cases where you'll have stars that are very close together, say like a white dwarf. This happens often with white dwarfs, which white dwarf is a much smaller star, and it's kind of death. It is kind of categorized as a white dwarf, and what it will do is it will pull materials from the surrounding stars, and those materials will increase the pressure and cause an explosion. So that's another way you can get a supernova. So what's really important about supernovas is that this generates a massive amount of energy, and this energy is going to cause atoms and materials and protons to collide with each other, and they will fuse together to make neutrons and the other elements on the periodic table. So you actually have so much energy generated that all the materials, especially those from iron up, can generate in even very, very small supernovas. Now, the very large supernovas, very, very large, massive stars, will cause some of the heavier metals to be generated. So this is where you can get some of your lead and your uranium created, is from a massive, very massive supernova. Another reason why supernovas are important is because of the amount of light that supernovas create or generate. Scientists can actually use this light kind of as a meter stick or a ruler. It allows them to measure distances. So since we know the speed at which light can travel, we can actually measure how far away some of these galaxies are in which we see these supernovas. And it also creates kind of a contour to the galaxies that we have around us. So the light coming back at us can actually create shapes, and we can actually figure out the interior shape of these galaxies. Now, after the supernova occurs, of course, we have the generation of all the elements necessary for not only planets, other stars, and also even life, like we find here on Earth. It tends to be the birthplace of new stars, because there's so much energy. And what's really kind of cool about supernovas is what's called a neutron star will actually form inside of the supernova, and that neutron star is all the densest materials that were from the explosion. They all kind of condense down in the center. This is, by the way, what is suspected to make like Thor's hammer. And so it's a very, very dense, very, very small space in which everything is compacted. And then surrounding that neutron star is the nebulas, or the nebula, which is pretty much a gas cloud of the remaining lighter materials. And these are going to be locations that we consider stellar nurseries, where there's enough material, there's enough energy. The neutron star can generate a magnetic force field around it to where it causes an increase of energy. That increase of energy allows additional colliding of molecules so that you start getting additional stars forming, planetary bodies, solar systems within that little nebula. Supernovas in our own galaxy, the Milky Way, don't happen extremely often, maybe 2 to 3 per century. And so we really don't get a massive amount here in the Milky Way. And what we do get in the Milky Way sometimes is a little clouded from view due to all of the materials that are floating in the Milky Way. However, scientists can actually see other supernovas that are happening in other galaxies, and so they are able to gain quite a bit of information from those. But within our own Milky Way galaxy, not a whole bunch of these supernovas occur. Again, mostly because they would be rather close to us and potentially a little bit more dangerous. And lastly, sometimes supernovas can generate such a gravitational pull inward that it actually converts into a black hole. Black holes are going to have such an intense gravitational pull that they don't even let light escape. So we can't really actually see them. We can only see where one is based upon the absence or the lack of light. So supernovas can become black holes. But again, that's only going to happen with the largest of the massive stars. Well, this is my presentation on supernovas. I hope you enjoyed it. Have a great day.